Hello students, happy morning. Class 12 Physics, Unit 1, Electrostatics Revision Continuation video. Here in this session, let me see the book bag questions from the subtopic, that is capacitor and capacitance. Okay, let me go for the questions. Our first question, that is very short answer question. Define capacitance, give its unit. Okay, for this question, we have to recall the expression C is equal to Q by V. By knowing this expression, we can easily define what is capacitance. Okay, capacitance, it is a ratio of charge given to the conductor to the potential developed between the conductors. Okay, here let me see the actual definition. It is defined as a ratio of magnitude of the charge on either of the conductor plate to the potential difference existing between them. Okay, see, first question, that is capacitance. Very short answer question. First question, capacitance. For this, we need to know C is equal to Q by V. Okay, capacitance is a ratio of charge given to either of the conductor plate to the potential difference existing between the conductors. Okay, the unit of capacitance, that is farad, or we can write the unit of charge is coulomb, the unit of potential difference is volt, then coulomb volt inverse. Okay, then second question, what is meant by electrostatic energy density? Okay, for this you have to know this expression. Okay, UE is equal to U by volume. This U is a energy stored in the capacitor. Okay, then energy stored per unit volume is known as energy density. Okay, the energy stored per unit volume of space is defined as energy density. Energy stored per unit volume of the capacitor is known as energy density. Okay, then let me move for the long answer question. Obtain the expression for capacitance of the parallel plate capacitor. Okay, here for this question we have to calculate the capacitance of the parallel plate capacitor. Okay, we need to find the capacitance of the capacitor. Okay, for that we have to consider a parallel plate capacitor. Okay, having the cross section area A and having the charge Q. Okay, then the electric field between the two infinite parallel plate, that is we know E is equal to sigma by epsilon naught. Okay, then here it is a sheet. Okay, capacitor having the two conductor sheet having the charge density, that is sigma is equal to Q by A. Then electric field between the plates, that is E is equal to sigma can be written as Q by A, then Q by A epsilon naught. Okay, then the electric potential between the plates having the separation D. Okay, that is we know V is equal to E into D. We know the value of E, substitute here, then we get this expression. Okay, then we need to find the capacitance. We know capacitance is the ratio of charge to the potential difference between the conductor. Then we know Q, we know the value of V, that is V is equal to Q D by A by epsilon naught. Okay, on solving this we get epsilon naught A by D. Here C is equal to epsilon naught A by D is a actual relation for capacitance. Okay, capacitance depends on the geometry of the capacitor, that means area of the capacitor and the distance between the capacitor plate. Okay, see, capacitance is directly proportional to the area of cross section. Okay, and inversely proportional to the distance between the plates. Okay, if area increases, what happen? Charge also increases. Okay, if distance decreases, then potential decreases. If potential decreases, then capacitance increases. Okay, let me see what are the important things needed to answer the question. Okay, first of all we need to draw a capacitor. Okay, capacitor consisting of two infinite parallel plates. Okay, one plate having the charge positive, charge density sigma plus, another plate having the charge density, that is sigma minus. Okay, they are separated by distance d. In between the capacitor plate there will be a confined electric field. We know very well electric field start from positive charge that terminate with a negative charge. Okay, these two plates having the area A. Then we know the electric field between the two infinite parallel plate, that is uniform. The value of the electric field will be E is equal to epsilon sigma by epsilon naught. Okay, here we know sigma is a surface charge density, that is Q by A. On substituting this, then electric field became E is equal to Q by A epsilon naught. Okay, we need to find the potential between the two plates. Okay, then potential difference V is equal to E into D. Substitute here, then Q by A epsilon naught D. Okay, then we need to find the capacitance. We know capacitance is equal to C is equal to Q by V. Q by V became Q D by A epsilon naught. Cancelling this, we get A epsilon naught A by D. This is a actual expression for capacitance. Okay, capacitance increases with the increase in area and decreases with the decrease in distance. Okay, C is directly proportional to area. If area increases, capacitance increases, and C is inversely proportional to distance. That means if distance decreases, capacitance increases. Okay, then let me go for the next question. Obtain the expression for energy stored in a parallel plate capacitor. Okay, we need to find what is the expression for the energy stored in a parallel plate capacitor. Okay, we know capacitor is not only the charge storage device, it also store energy. That energy is known as electrostatic potential energy. Okay, see, if suppose I consider a capacitor like that, then if it is connected with a battery, it will move the charge. Okay, if suppose it moves minus Q charge from one plate to another plate. Okay, by taking some energy from the battery. Okay, so the battery provides some energy, that is it did some work. Okay, then to transfer the charge, the work is done by the battery. This work done is stored as a electrostatic potential energy. Okay, by getting the energy from the battery, it store electrostatic potential. That work done is converted into electrostatic potential energy. Okay, to transfer an infinitesimal charge, that means small charge. Okay, that is represented by dq from for a potential difference V, the work done can be written as dw is equal to V dq. Okay, we know V is equal to Q by C. That means C is equal to Q by V. We get V is equal to Q by C. Substitute in this expression, then we get like this. Okay, we need to find total work done. Okay, total work done means we have to integrate this small work done by applying the limit 0 charge to maximum charge Q. Okay, then integrating this, we get Q square by 2C. Okay, this work done is nothing but the electrostatic potential energy of the capacitor, that is represented by UE is equal to Q square by 2C. We know Q is equal to CV. Okay, substituting this, we get half CV square. Okay, then energy stored per unit volume. Okay, if suppose we know C is equal to epsilon naught A by D and V is equal to E into D. Okay, substitute in this expression, we get like this. After, then we get 1 by 2 epsilon naught AD into E. Here A into D, area into distance, that is nothing but a volume. Okay, then energy stored per unit volume can be written as half epsilon naught E square. Okay, here this energy stored in the confined electric field, okay, that are existing between the plates of the capacitor. Okay, here the energy density depends only on electric field. Okay, let me see what are the important things needed to answer this question. First of all, we need to consider a capacitor setup. Okay, two plates having the same area, having the same surface charge density at a distance d, it produces electric field. Okay, that is C. Here it is sigma, here also it is sigma plus, it is sigma minus. Okay, here capacitor is not only store the charge, it also store energy. That energy is known as electrostatic potential energy. Okay, if suppose this capacitor is connected with a battery like this, okay, then this plate will transfer the charge minus q from this plate to this plate. Okay, so it does some work by getting some energy from the battery. Okay, that work done to move a small charge, that is infinitesimal small charge dq from plate A to plate B, that is represented as dw is equal to v dq. Here dq is a small charge that can be moved from plate A to plate B by applying the potential V. Okay, then we know V is equal to Q by C. Okay, in order to find the total potential energy, that means in order to find the total work done did by the capacitor, okay, did by the battery. So far we need to integrate the small work done, then we get integration of V dq, substitute V is equal to Q by C, then total work done, that is V is equal to integration of Q by C dq. Okay, 1 by C is taking out of the integral, that is constant, then Q dq. Integrating Q dq over the limit 0 to Q, because 0 to Q, that means 0 charge to it transfer maximum charge Q. Okay, then work done W is equal to 1 by C Q square by 2. Okay, applying the limit 0 to Q, then we get Q square by 2C. Okay, this work done is nothing but the electrostatic potential energy. Potential energy, that is equal to U, that is equal to Q square by 2C. Okay, then we know Q is equal to CV. Okay, substitute in this expression, then energy U is equal to C square V square by 2C. Then solving this, we get U is equal to half CV square. Okay, then after we know capacitance can be written as C is equal to epsilon naught A by D, and the potential difference V is equal to E into D. Okay, substitute these two expression in the above expression. Okay, then substitute the capacitance value and potential value to the electrostatic potential energy, then we get U is equal to half C became epsilon naught A by D, V became V square. Okay, that is E D whole square. Okay, after solving this, U is equal to 1 by 2 epsilon naught A by D E square D square. Okay, 1 D cancel, then U is equal to half epsilon naught A E square. Okay, 1 D is there. This is the energy stored in the parallel plate capacitor. Okay, in order to find the energy stored per unit volume, okay, U is equal to 1 by 2 epsilon naught E square AD. Okay, here A is the area and D is the volume. Sorry, D is the distance. Then area into distance became volume. AD is equal to volume. Okay, then dividing this energy by volume, we get 1 by 2 epsilon naught E square. This is known as energy density UE. Okay, this energy density depends only on the electric field. Okay, it does not depends on the area or distance between the two capacitor plate. Okay, it depends only on the electric field. Okay, this energy is stored in the confined electric field alone. Okay, our next question, explain in detail the effect of dielectric placed in a parallel plate capacitor. Okay, here in this question we will explain what is the effect of dielectric when it is placed in between the parallel plate capacitor. Okay, here we are following the two situation. First situation, when the capacitor is disconnected from the battery. Okay, first of all I consider a capacitor that is connected to a battery. Okay, then disconnecting the battery, I am inserting the dielectric medium. Okay, at that case we have to find what is the electric field, what is the potential difference between the two plates, what is the capacitance, what is the energy, and what is the charge in the capacitor. Okay, we need to find 5 things. What are that? Charge, capacitance, electric field, potential difference, and energy stored in a capacitor. Okay, let me see first case. When the capacitor is disconnected from the battery. Okay, here I am disconnecting the battery from the capacitor. Okay, after that I am inserting the dielectric medium. Okay, second picture. For that condition, see, the capacitor is charged by the battery of voltage V0 and the charge stored is Q0. Okay, so the charge in the capacitor will be constant. Okay, for this case, which one is constant? The charge in the capacitor plate will be constant. Okay, see, after inserting the dielectric medium, the number of lines, what happened? The number of lines decreases. So electric field also decreases. See, the capacitance of the capacitor without the dielectric, that is C0, it is represented as C0. In this case, C0 is equal to Q0 by V0. Q0 is a charge and V0 is a potential between the capacitor plate before the dielectric is placed. Okay, here C0 is a capacitance of the capacitor before the dielectric is placed. Okay, then the potential between the two plates, that is V0 is equal to E0 D0. These are the things before the dielectric is placed. Okay, after the dielectric is placed, the electric field decreases, that is E is equal to E0 by epsilon R. Okay, here we know E0 is a electric field inside the capacitor when there is no dielectric medium. Before the dielectric place, the electric field will be E0. Okay, after it is placed, the electric field will be decreases. This can be represented by the expression E is less than E0. Okay, we know V is equal to E into D. Okay, here electric field decreases, so the potential difference between the two plates also decreases because V is directly proportional to E. Okay, so it is reduced. Then next, what is the potential? Okay, for the second case we have to find, that is V is equal to E into D. We know E is equal to E0 by epsilon R. Substitute here. Then we know E0 into D, that is V0. Then V is equal to V0 by epsilon R. So I already told the potential also decreases. In order to find new capacitance, we know the capacitance formula C is equal to Q by V. Then C is equal to Q0 because charge never change. It is a constant by V. V is equal to V0 by epsilon R. Okay, substituting this we get Q0 by V0 is equal to C0. Then here the capacitance increases epsilon R times, so capacitance increases. Okay, see, this is a capacitance of the capacitor when the dielectric is placed. Okay, then we can write that is C is equal to epsilon A by D. Okay, then energy stored in the capacitor before the insertion of dielectric, that is U0 is equal to half Q0 square by C0. Okay, after the dielectric is placed, Q0 never changed, but C0 became C. Okay, we know the value of C, that is epsilon R C0. Okay, substitute here, then we get U0 by epsilon R. So the energy also decreases. Okay, let me see what are the things needed to answer the questions. See, first of all we need to draw a capacitor circuit that is connected with a battery. Okay, after that is break. Then we are inserting the dielectric medium. Okay, here we know the charge initially the before the dielectric place, the charge in the capacitor will be Q0. Okay, electric field is E0. Then the potential difference between the capacitor is V0. Okay, after the dielectric is placed, the charge is again Q0, but the electric field is E and the potential is V. Okay, then the capacitance for initial case, that is C0. Here it is C. We need we will see one by one. First of all, let me see the capacitance. Okay, capacitance for this case, that is C is equal to Q0 by V0. Okay, then the electric field for the first case, that is that is E. Okay, then the potential difference that is, sorry, this is E naught, this is V naught. Okay, then the dielectric is placed. At that instant C became, sorry, this is C naught, it became C, that is equal to Q naught. Okay, because the potential never changed, that became V. Okay, then the electric field, that is E is equal to E naught by epsilon r, because we are placing the dielectric between the parallel plate capacitor. Okay, so the electric field decreases. Due to decrease in electric field, the potential also decreases. V is equal to, we know, E into D. Then V is equal to E naught D by epsilon r. Okay, this we know very well, that is V naught. Okay, then V is equal to V naught by epsilon r. Then potential also decreases. Okay, then substitute in this expression, then C is equal to Q naught by V became V naught epsilon r. V naught epsilon r. This we know, C is equal to epsilon r, Q naught by V naught, that is C naught. Capacitance also, capacitance increases. Okay, what are the major things? First of all, charge Q naught is constant. Okay, after the dielectric is placed, electric field E is decreased. Due to the decrease in electric field, potential difference between the parallel plate capacitor also decrease. Then capacitance, that is increased. Then finally the energy, that is decreased. Okay, that is because, see, we know U naught, that is the energy between the parallel plate energy of the parallel plate capacitor when the dielectric medium before placed, that is U naught is equal to 1 by 2 Q naught square by C. Okay, sorry, Q naught square by C naught. This is the initial energy of the parallel plate capacitor. After the dielectric is placed, it became U 1 by 2 Q naught square, because charge is never changed. C naught became C. Okay, we know C is equal to epsilon r C naught. Okay, then this entire term become U naught by epsilon r. This implies the energy will be decreased. Okay, then let me see the next case. When the batteries remain connected to the capacitor. Okay, here in this case we are inserting the dielectric at the instant when the battery is connected with the capacitor. Okay, for this, here for this two things are constant, because the battery is connected with the capacitor plate, so the potential difference between the plate is constant. Due to the constant potential difference, then the electric field also constant. Okay, then what are the things will be vary? The charge will vary, then after capacitance vary, and the energy also varies. Okay, see, first of all, the charge stored in the capacitor, that is increased by the factor epsilon r. Then Q is equal to epsilon r Q naught. Okay, we know C is equal to Q by V naught. Okay, C is equal to Q by V naught. Here the capacitance of the parallel plate capacitor after the dielectric medium is placed, that is C is equal to Q by V naught. Because we are putting V naught, the electric field, the potential is constant. Okay, then Q is equal to epsilon r Q naught. Then Q naught by V naught became C naught. Okay, the capacitance by showing the expression capacitance C is equal to epsilon r C naught, that implies capacitance increases. Okay, then we have to find the energy, that is U naught is equal to half C naught square V naught square. This is the energy of the capacitor before the dielectric medium placed. Okay, after the dielectric medium placed, then energy became U is equal to 1 by 2 C V naught square. Okay, we know the value of C is epsilon or C naught. Substituting this we get epsilon or U naught. Then the energy increases. Okay. The next energy stored per unit volume, that is U is equal to half epsilon E naught square. We know here the potential and electric field are constant, so the energy density also constant. It never change because the energy density depends on electric field. Okay. Here in this case the batteries remain connected with the capacitor. Okay. So we are drawing the picture like this. The batteries remain connected with the capacitor, but we are inserting the dielectric medium inside the capacitor. Okay, when the battery is connected with the capacitor, at that instant we know the electric field before the dielectric medium is placed E naught, then the potential also V naught, then the charge is Q naught at that instant. Okay, after the dielectric medium is placed, at that instant the electric field never change and the potential never change. Okay, but the only change is charge increases. Okay, then Q is equal to epsilon r times it will increases. Okay, then we know capacitance C is equal to Q by V. Okay, here charge Q by V naught, because the potential never change. Okay, this one became epsilon r Q naught by V naught. Okay, this one we know, that is C naught. Then capacitance C is equal to epsilon r C naught. Okay, here this shows capacitance increases. C is greater than C naught. Okay, then after we need to find the energy. We know U is equal to half CV square. Okay, then U naught is equal to half C naught V naught square. This is the energy stored in the capacitor before the dielectric is placed. Okay, after the insertion of the dielectric medium, it became U. Then U is equal to half C, this is V naught square, because the capacitance will increases and the potential is constant. Then we know the value of capacitance. C is equal to epsilon r C naught V naught square. Okay, then we can write U is equal to, this one is nothing but the U naught. Okay, this one is epsilon r. This one shows the energy will increases. Energy will increases. At the same time, energy density U is equal to half epsilon E naught square. Okay, this shows the electric field, the energy stored in a confined electric field that depends only on the electric field. So after the insertion of the dielectric medium, it does not change the energy stored per unit volume. Okay, okay students. Today class is completed. You have to make a key points for these questions. Okay, this is a assignment. You have to make key points for these questions like this. Okay, thank you.